Hello everyone. In this session, we will detect the horizontal edge on a given input image by convolution. Now, what is horizontal edge? Horizontal edge is basically a boundary that discriminates two regions in a horizontal direction. Now, consider the image shown on the screen in the grayscale mode with 15 by 15 dimensions. The image has black portion on the top and white portion on the bottom bifurcated by a horizontal boundary. The black pixels are represented by zeros and white by ones. This image has to be convolved with an horizontal edge filter to detect the boundary. Now here on the next slide, we have the input image that can be convolved by a 3 by 3 horizontal filter. The filter has ones, zeros, and minus ones in the first, second, and third rows respectively. This filter shall be used to detect the horizontal boundary on the input image. Now let us look into the Python code and see how we can implement a horizontal edge detector. In the previous session, we had discussed vertical edge detection, and the same steps are to be followed here in processing the input image and the kernel that needs to be convolved with. The input image is pulled into a NumPy array whose size is computed into an image size called as nsize or NSZ. Here, the input image shall have both rows and columns at same size. The input image here shall have zeros in the first half of the input matrix and ones in the bottom half of the matrix, showing the separation of the boundary on the horizontal edge. In the next section, we define the kernel or the filter of size 3 by 3 with horizontal masking. We compute the size of the filter into FSZ, which is called the filter size. Further, in the last section, we shall compute the size of the convolved image into conv size as the difference of the image size and the kernel decremented by 1. The convolution image is initiated with zeros, and for every iteration equal to the convolution size, the filter is moved across the image to create a pool. For every element in the filter, its corresponding element in the pool is multiplied. The results are summed up and stored in the convolution image, which is finally printed out. Observe the results on the screen and note that the boundary on the horizontal image is marked by -3 across. The final image that we see here shows the convoluted state of the original image and the horizontal boundary marked very clearly. Thanks for hearing and watching. You had been hearing so far on my channel cumulonimbus.ai. If you like the kind of videos that I'm making in this web series, please do consider subscribing to my channel and like them. You can tap the link on the GitHub given here for the source code, clone them, and play around. Happy learning and catch you soon with my next video. Until then, cheers. Sridhar.